Hello and welcome to Math 055. This is the last section over 8.6 and 8.7. And before we get into the notes, I want to show you guys an animation of something that I call a parabola in vertex form. So I have my vertex form here, and that's going to be the equation y equals a times x minus h quantity squared plus k. All right, and so we have this parabola here. Now the cool thing is that I can manipulate the numbers for a, h, and k, and they do different things to the graph. So I'm going to go ahead and play this animation real quick so that you guys can see what that looks like. And so notice here that a is changing. Okay, and when a is negative, the graph opens down. When a is positive, that graph opens up. Okay, and so that's just going to flip it around. Now, get it back so it's shaved up. All right, and then if I move k is this outside number here, and all that does is it moves the graph up and down. Okay, so that's going to be a vertical shift. A flips it across the x-axis, and then if I manipulate h, what happens is that graph moves left to right, okay? And those are the different transformations of the graph. Now, if I manipulate all three of them, then the graph is just going to do some crazy stuff, and, you know, we'll just go from there. So, all right, so let's go back to our notes here, okay? And what we're doing is we're going to be graphing our quadratic functions. Now, what we've been doing is we've been finding the x-intercepts, which is really important, but it's also important that we figure out the vertex, which is either a maximum value or a minimum value, the axis of symmetry, and then your x and y intercepts. So, to graph, let's write this down. So to graph, all right, so to graph, we need to first find the vertex, okay? And the vertex, the x value can be found by doing opposite b over 2a, okay? And then the y value means that I would plug in opposite b over 2a into the function to get my y value, okay? So the vertex, you know, you have this, it's a point, all right? And so this is a point, okay? And that's going to be, you know, let's just draw a generic parabola here, okay? Let's do something like that. Okay, and I want to denote that this point down here is my vertex. Okay, so we first want to find our vertex. Okay, and that's the point where it's either going to be our minimum or maximum. So point in that point is going to be the point opposite b over 2a. And then once to find the y value at that point, we have to plug that into our function opposite b over 2a. Okay. All right, so that's the first thing we want to find is our vertex. Now, it's either a maximum or a minimum, okay? It's a maximum if a is negative, okay, and that's your leading coefficient, okay? And it's a minimum if a is positive. All right, and that's that, okay? So that's what the vertex is. Okay, now the x-intercepts, so second thing you want to find is you want to find your x-intercepts, okay? And you do that, you find your x-intercepts by solving, here, let's do this, by setting your quadratic equal to 0 and solving for x. Okay, and solving for x. Okay, those are your x-intercepts. Now, the third thing that you want to find is your y-intercept. okay? And what you'd want to do for that is you'd want to let x equals 0 and solve for y. Okay, so not too terrible, okay, not awful. But let's just go through and let's identify here, you know, your x-intercepts, all right, are going to be here, all right, these are going to be your x-intercepts, and then this value right here is going to be your y-intercept. Okay, so if you can find those, then you can graph a quadratic. Okay, so it's not too bad. All right, now the other thing that I want to talk about is the vertex. Okay, so let's come in here. Let's talk about the vertex. So the vertex part 2. All right. When you have the equation y equals a times x minus h squared plus k, if you have it in this form, your vertex is of the form h comma k. Now it's important to denote that h, the value of h, is always opposite of what the equation says. Okay, so if you know, notice here how h, it's always negative, is negative here. When I write out my vertex, when I write the point out, then h value is always opposite of what it says. So let's take. Now, the other thing that's nice about the vertex, okay, is that it gives us our axis of symmetry. Okay. And the axis of symmetry is simply the x value of the vertex. Okay. And, you know, what I mean by that is, let's, you know, look up here, the axis of symmetry. If I take my vertex here, you know, it's this vertical line that goes up from my vertex, that goes vertically up and down, that that goes through my vertex. And what this does is that, you know, the parabola is symmetric to this line. Now my graph doesn't look very good, but, you know, that's what's nice about the vertex. Okay, so we have all that information from the graph. So on this part here, it says it wants us to graph the function and find the vertex, the axis of symmetry, and the maximum value or minimum value. So, you know, just off of this, I can identify what my vertex is. So my vertex is simply the value -3, -2. Now, the reason why that this vertex, the x value, is -3 is because it's opposite of what this number is here. Because this is x plus 3, that means that my vertex is going to be at -3, -2. Okay? Now, my axis of symmetry is going to be the line x equals -3. Okay? All right, now the a value is 1, okay, which is positive. All right, so my maximum, or we have to determine whether we have a maximum or a minimum. So because a is positive, that means that the graph is going to open up like this, which means that we have a minimum value. Okay, we have a minimum value. So the vertex here, my minimum value, is going to be the point -3, -2. Okay, and if a was negative, then we'd have a maximum value. Okay, now the other thing that I want to do, just to do it for this problem, is I want to identify what my x-intercept is and what my y-intercept is. Okay, so let's find our x-intercepts. Okay, so X-Intercepts. So X-Intercept. All right, and so my X-Intercept, what I want to do is I want to set my function equal to 0 and solve for x. Okay, now that's kind of nice with the problem that we're given. So 0 is equal to x plus 3 squared minus 2. All right, so if I wanted to solve this for x, I would simply just add 2 to both sides. And so I would get that 2 is equal to x plus 3 squared. Okay, take the square root of both sides. And so I get that the square root of 2 is plus or minus the square root of 2 is equal to x plus 3. I'm going to subtract 3 from both sides. And so I get that x is equal to -3 plus or minus the square root of 2. Okay, so we'll look at that here in a second. The other thing I want to find is my y-intercept. Okay, and in my y-intercept, I want to let x equal 0 and solve for y. So I've got y equals, I'm going to do 0 plus 3 squared, and then minus 2. Okay, and so I get that y is equal to, this is 3 squared minus 2, which is going to give me 9 minus 2, which is going to give me 7. Okay, so y-intercept, that's going to be the point 0, 7. All right, so let's do that. Let's graph some of these points. I'm going to find my minimum value first, which is -3, -2. And so 1, 2, 3, 1, 2. Okay, here's my minimum value. My y-intercept, the next like clearest point that I can graph is the point 0, 7. So 1, 2, 3, 4, 5, 6, 7. We're going to plot that there. The other thing I'm going to plot is my axis of symmetry, which is along the line x equals -3. Okay? And the thing that I know about this is that, you know, this point lies on my axis of symmetry, okay, my vertex. This point here is 3 units away from my axis of symmetry. That means that another point would have to be 3 units away over here. 1, 2, 3. Okay, let me plot that point in black. All right, and so what I know is I have those 3 points, and I can simply just draw in my parabola. Now, it doesn't look very good, but that's the idea. Okay, now I could plot these points here to show my, you know, X-intercepts, but because I don't have nice, neat X-intercepts, that's really not that big of a deal. So, you know, you can kind of get around this. You know, you can always find all these values. Okay, you can always find your axis of symmetry, your vertex. You can always find your, you know, X-intercepts and your Y-intercepts, but it just depends on how you want to graph it to make it work, okay? And so let's label this. This here is my axis of symmetry. Okay, this point down here is my vertex / minimum. Okay, and then these points here are my X-intercepts. And then this point here is my Y-intercept. Okay, and that's what we got. All right, let's take a look at the next one. Okay, in this one we have the value f of x is equal to -2 times the quantity x plus 1 squared plus 4. All right, so let's come in here. Let's first find the vertex. All right, so the vertex is going to be the value -1, 4. Okay, what else do we need to find? Axis of symmetry is going to be at -1, so axis of symmetry is going to be x equals -1. Okay, and then because a is -2, Okay, so the A value here is equal to -2. That means that we are going to have a maximum, okay? And the maximum value is going to be the same point as your vertex, which is -1, 4, okay? And then let's find our X-intercepts. Okay, so let's do X-intercepts. So I'm going to set 0 equal to -2 times x plus 1 squared plus 4. Now what I'm going to do is I'm going to isolate my binomial here. I'm going to subtract 4 from both sides. Okay, and I get -4 is equal to -2 times x plus 1 squared. I'm going to divide everything by -2, divide by -2. All right, so I get that 2 is equal to x plus 1 squared. Okay, I'm going to take the square root, both sides. And so I get that x plus 1 is equal to plus or minus the square root of 2. Subtract 1 from both sides, so I get that x is equal to -1 plus or minus the square root of 2. All right, so that's my x-intercepts. Now those aren't going to work out nice and neat. So let's go ahead and find our y-intercept. Okay, y-intercept. And we're going to get y is equal to -2 times 0 plus 1 squared plus 4. All right, and so that's going to give me -2. Y equals -2 times 1 squared plus 4. So y is equal to... what is that? -2 times 1 plus 4. So we get y is equal to -2 plus 4, so y is equal to 2. Okay, and so that's the idea. So let's go ahead and plot our vertex at -1, 4. So -1, 1, 2, 3, 4. Okay, y-intercept at 0, 2. Let's go ahead and add in our axis of symmetry here. All right, let me just... And so because this point is 1 unit away from my axis of symmetry, I'm going to have it go down like this, and then down like this, okay? And so what I want you guys to see here, let's go ahead and I'm going to graph both of these on Desmos and have them pop up on the screen here, and that way we can see what these graphs are supposed to look like, and just check our work. Okay, so that's the cool thing about a lot of these graphing softwares is that you check your work and see if you've done it right. So on this first one, notice that we have a minimum at -3, -2. Okay, that's what we had. That's what we get when we graph it. See how nice and neat that looks? Mine looks terrible. But then look at the y-intercept at 0, 7. Okay, so some of those points are really important for us to graph. Same thing over here. We had a minimum value of 1, or a maximum value of 1, -1, 4, and that's what we graph here. And then we have the y-axis, which is the point 0, 2. Okay, so you can graph these and check, but you do need to be able to show your work and do it by hand. But it is nice to check to see that you've done it right. Okay. Okay, so on this last one, we're given a function that isn't in vertex form. Okay, so what we want to do is we want to first, find the vertex, find the axis of symmetry, find the x-intercepts, find the y-intercept, and then graph. All right, so this one isn't as bad. So let's, on part A, let's find the vertex. All right, so the vertex. And that's going to help. We're going to get that by doing x equals opposite b over 2a. All right, so the first thing I want to do is identify what my a value is. So a is equal to 1, b is equal to -6, c is equal to 5. All right. So let's calculate that vertex first, okay? So let's do x is equal to opposite b, so it's going to be 6. So 6, opposite 6, over 2 times 1. So the x value of my vertex is going to be the value of 6 divided by 2, which is 3, okay? Now for me to find the y value, I want to find f of 3 and plug in 3 for x. Okay, and so I'm just going to plug that in. So I'm going to get 3 squared. So 3 squared minus 6 times 3, and then plus 5. Okay, so 3 squared is going to give me 9, minus 18, and then plus 5. Okay, so 9 minus 18 is going to give me negative 9, and then plus 5, so that's going to give me a value of negative 4. All right, so f of 3 is equal to negative 4. Now remember that this notation means that I just have the point 3 comma negative 4, and that's my vertex, okay? Now my axis of symmetry, part B, all right, my axis of symmetry is simply the line x equals 3, okay? So that's that. All right, now the next part, part C, find the x-intercepts if any. So I'm going to set my whole thing equal to 0, so I've got x squared minus 6x plus 5. Now, I want to see if this is factorable first. So two numbers that multiply to 5 but add to negative 6 is going to be negative 1 and negative 5. So I'm going to factor this, and so I get x minus 1 times x minus 5, okay? And that's how that's going to factor. So then I set each of my factors equal to 0, so x minus 1 equals 0, and then I set x minus 5 equal to 0. So add 1 to both sides, so I get x is equal to 1, add 5 to both sides, so I get that x is equal to 5. Okay, these are my x-intercepts. So I'm going to write that here. X-intercepts are the points 1 comma 0 and then 5 comma 0. All right, so that's my x-intercept. All right, part D wanted us to find the y-intercept, so I'm going to do y equals, plug in 0 for x, so 0 squared minus 6 times 0, and then plus 5. Okay, that's going to be 0, that's going to be 0, add it to 5, you get the value y equals 5. So then my y-intercept is the value 0, comma 5. All right, and then, all right, so that's it. All right, so we've done everything we need to do. Okay, so let's find my vertex here, 3, negative 4. All right, so let's go over 3, 1, 2, 3, over down 1, 2, 3, 4. Okay, I have the point 1, 0 and 5, 0 as those values, and then what was my y-intercept? 0, 5. Okay, so 1, 2, 3, 4, 5. All right, and so this is what's going to give me my parabola, just like that. Okay, and then I'm going to put that point in there. You know, you can come in here and you can label your axis of symmetry. Okay, and you know, we can go through these as such, but that's the idea. So, you know, let's go ahead and label these on the graph. You know, here's my vertex, here's my x-intercepts, and then this value here was my y-intercept, okay? And that's that, okay? So hopefully, and let's go ahead and graph this too, and let's just verify that we get the same thing. Okay, so let me add that photo in to here. All right, and let's just take a look at this. All right, so here's what we got. You know, if we look at these same points, all right, you know, my vertex was at 3, -4. X-intercepts were at 1 and 5, and then my Y-intercept was at 5, okay, which is the same thing that we got here. So, you know, we did it right. And, you know, and that's the thing, guys, is, you know, use these tools to help you understand. Don't use them to do the work for you. Obviously, if you're really stuck on something, you know, use those tools to kind of help. So here's your homework for 8.6 and 8.7. This is the last video for the course, and hope you enjoyed watching these. And if you got any other questions, give me a holler. Thanks a lot. We'll see you in a bit. Bye.